children, this class is for standard 8 and the subject is mathematics. In this class, we are going to cover chapter number 14, visualizing solid shapes, exercise 14.2. Topics covered in this class are various kinds of solids, counting the vertices, edges and faces, Euler's formula. Various kinds of solids. Sphere. Sphere is a circular solid. Every point on the surface is at the same distance from the center. A sphere contains no vertex and no edge. Only one curved face of a sphere. A cricket ball, marbles are some examples for a sphere. Prism. Prism are solid figures which have a uniform cross section. The cross section is the constant shape which runs throughout the figure. Or a prism is a solid with end faces that are same and parallel and the side faces that are parallelogram. There are various types of prism. A prism is named according to its cross section. Some of the types of prism are triangular prism, rectangular prism, square prism, cylinder, pentagonal prism and hexagonal prism. Let us see one by one in detail. Prisms. Triangular prism. A triangular prism has a uniform cross section which is a triangle. The vertices of a triangular prism is 6 and the number of edges is 9 and the number of faces is 5. The number of triangular faces is 2 and the number of rectangular faces is 3. Rectangular prism. A rectangular prism has a uniform cross section which is a rectangle. Rectangular prism is also called as cuboid. The number of vertices in a rectangular prism is 8. The number of edges in a rectangular prism is 12 and the number of faces in a rectangular prism is 6. Rectangular faces equal to 6. Square prism. A square prism has its base and top as squares and 4 lateral faces as rectangle is called a square prism. A square prism has a uniform cross section which is a square. A square prism may be cube or cuboid. Number of vertices is 8. Number of edges is 12. Number of faces is 6. If the square prism is a cube, it contains 6 square faces. If the square prism is a cuboid, it contains 4 rectangular faces and 2 square faces. Cylinder. The cylinder has a constant cross section which is a circle. It is also called as circular prism. Number of vertices for a cylinder is 0. Number of edges for a cylinder is 2 curved edges and number of faces for a cylinder is 3. Flat face, it contains 2 flat face and curved face, it contains 1 curved face. Therefore, a cylinder consists of 2 flat faces, that is circle, and a curved face. Pentagonal prism. Pentagonal prism has a uniform cross section which is a pentagon. The number of vertices for a pentagonal prism is 10. The number of edges for a pentagonal prism is 15. The number of faces for a pentagonal prism is 7. Pentagonal faces 2 and rectangular faces 5. Hexagonal prism. A hexagonal prism has a uniform cross section which is a hexagon. The number of vertices for a hexagonal prism is 12. Number of edges is 18. Number of faces is 8. It consists of 2 hexagonal faces and the rectangular faces 6. Important note for in a prism. The number of vertices of a prism is twice the number of sides of its base. Similarly, the number of edges of a prism is thrice the number of sides of its base. The number of faces is 2 more than the number of sides of its base. Cone. A cone is a solid figure which has a circular base. Its all other surface come to a point. Pyramid. A pyramid is a solid figure which stands on a flat base which may be a triangular, a square, a rectangular or a polygonal. It tapers to a point which means that each of its sides is a triangle, or a pyramid has a plane figure for a base and all the other sides are triangular meeting at a point. A pyramid is named based on the non-triangular face. If all the faces are triangular, then it is called as triangular pyramid. Some types of pyramid are triangular pyramid, square pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid, octagonal pyramid. Let us see one by one in detail. Triangular pyramid. A triangular pyramid has vertices 4, edges 6 and triangular faces 4. Rectangular pyramid. A rectangular pyramid has vertices 5, edges 8 and faces 5. In these faces, it has 4 of its faces are triangular and 1 of its faces rectangular. Square pyramid. A square pyramid has vertices 5, edges 8, faces 5. In these faces, it consists of triangular faces 4 and a square face. Pentagonal pyramid. A pentagonal pyramid has 6 vertices, edges 10 and faces 6. In this 6 face, 5 of its face are triangular and 1 of its face is a pentagonal. Hexagonal pyramid. A hexagonal pyramid has vertices 7, edges 12, faces 7. Out of these 7 faces, 6 of its faces are triangular face and 1 of its faces hexagonal. Octagonal pyramid. A octagonal pyramid has vertices 9 and edges 16, faces 9. Out of these 9 faces, it has triangular face 8 and octagonal face 1. Important note for a pyramid. In a pyramid, the number of vertices is 1 more than the number of sides of the polygonal base. Similarly, the number of edges is twice than the number of sides of the polygonal base. The number of faces is 1 more than the number of sides of the polygonal base. Polyhedrons. A solid shape made up of polygonal regions which are its faces is called as a polyhedron. Therefore, a cube is a polyhedron whereas a sphere is a non-polyhedron. Cuboid, polyhedron, cone, non-polyhedron, triangular prism, polyhedron, cylinder, non-polyhedron, hexagonal pyramid, polyhedron. Therefore, a solid shape made up of polygonal regions is called as polyhedron and the remaining are called non-polyhedron. A polyhedron can be divided into 2 types which are called as convex polyhedron and concave polyhedron. If the line segment joining any 2 points on the surface of the polyhedron entirely lies inside or on the polyhedron is called as convex polyhedron. For example, a hexagonal prism, a triangular pyramid. These are an example for convex polyhedron, whereas if the line segment joining any 2 points on the surface of a polyhedron entirely lies outside the polyhedron, which is called as concave polyhedron. The example is given below. Regular polyhedrons. A polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. This is an example for a regular polyhedron. This is a regular tetrahedron. Vertices 4, edges 6, faces 4. Similarly, this is also another example for regular polyhedron. The name for this shape is a regular octahedron. The number of vertices is 6, edges 12 and faces 8. Euler's formula. Leonhard Euler was a Swiss mathematician. One of his most remarkable observations gave a relationship among the number of vertices and edges with faces of a polyhedron. To study the relationship among the number of vertices, edges and faces, let us consider 4 examples. The first one is tetrahedron, second one is cube, octahedron and the last one is pentagonal prism. Let us have a table which contains the shapes and the number of faces is described by F, number of vertices is described with V and the number of edges is described with E. Euler gave a simple definition which describes the relationship among the number of vertices, edges and faces. For tetrahedron, number of faces is 4, vertices which is equal to 4, therefore F plus V which is equal to 8 and number of edges equal to 6. By subtracting the faces and vertices with edges, we get the result as 2. Similarly, for cube, the number of faces is 6, vertices is 8. So, F plus V which is equal to 14 and the number of edges equal to 12. So, 14 minus 12 which is equal to 2. Similarly, for octahedron, the number of faces is 8, vertices is 6, faces plus vertices equal to 14 and the number of edges is 12. So, 14 minus 12 which is equal to 2. Similarly, for a pentagonal prism, the number of faces is 7, vertices is 10. So, 7 plus 10 equal to 17 and the number of edges is 15. So, 17 minus 15 which is equal to 2. Therefore, he gave a simple relationship among the number of vertices, edges and faces as F plus V minus E equal to 2. Exercise 14.2. The fifth problem. Find the number of faces, edges and vertices in a prism pyramid whose base is a polygon of side n. Solution. Given the side as n. Therefore, in a prism, the faces is n plus 2 and edges equal to n into 3. Similarly, vertices equal to n into 2. In a pyramid, faces equal to n plus 1, edges equal to n into 2 and vertices equal to n plus 1. Seventh problem. A polyhedron has 13 edges and 20 vertices. How many faces does this polyhedron have? Solution. Given number of edges equal to 30 and number of vertices equal to 20. And we need to find the number of faces. Using Euler's formula, we know that F plus V equal to E plus 2. By substituting the value of E as 30 and V as 20, we get the equation as F plus 20 equal to 30 plus 2. Therefore, F plus 20 equal to 32. By taking the constant towards the right hand side, we get F equal to 32 minus 20, which is equal to 12. Therefore, the number of phases for the given polyhedron is 12 phases. Thank you, children.